do two problems that are reaction stoichiometry. We're going to do mole-mole and mole-mole gram. I doubt very seriously we get to the one that I have labeled if time up there. Now, for us to be able to do this, we need exactly one new skill. Once we learn this one new skill, all we have to do are combine skills that you guys already have, okay? So the one new skill that we need is called a mole ratio. So today, we're going to learn how to write a mole ratio. I've been telling you for weeks that moles are going to lose their ability to stay a 1. Well, today is the day that they're losing their ability to remain a 1. Okay? A mole ratio is a conversion factor that allows us to change from one compound to another compound in a chemical reaction.
Is this like a new subject?
Yes, this is stoichiometry. Okay? A mole ratio is a conversion factor that allows us to change from one compound to another compound in a chemical reaction. Really? So, if we go back to what we were doing the other day, all right, when we wrote down reaction stoichiometry, I said something like we could go from grams of Na to grams of Cl2. I don't remember what the actual example was I wrote down. However, anytime we do reaction stoichiometry, we can change from one compound into a completely different compound, right? Well, in order to do that, what are we going to need to be able to do this? A mole ratio allows us to change from one compound into another, okay? Without a mole ratio, we can't do that. So we need to learn how to use a mole ratio today, and then we'll be able to change from one compound to another. That's the key to today's lesson, really today's and tomorrow's. So, how are we going to do this? Now, here's a standard chemical reaction that every person in the room can balance. Everybody in here could do a reaction like this on the test yesterday. Even those of us who are struggling with balancing can do these. So, when we look at this reaction, what is the first element we should balance? I would certainly start with oxygen myself. So there are how many oxygens here? And how many here? So everybody would have said put a what here? And put a what here? Now, how many FEs is that? So we'd put what here? Now, the thing about mole ratios and being able to write one is we have to know how many moles are in the reaction based on what we just did. Well, moles are coefficients. So when we want to find the number of moles of iron, what coefficient is in front of iron? So there are 4 moles of iron. How many moles of oxygen are there? See how we got some of those numbers varied? What did I say told us the moles? So there are how many moles of oxygen? 3. Now, a couple people said 6 because it's tempting to say 3 times 2 and yell out 6. There aren't 6. The coefficient in front of oxygen is a what? 3. There are 3 moles of oxygen because the coefficient in front of the oxygen is a what? 3. Okay, we don't multiply, it's just 3. What coefficient is in front of iron 3 oxide? Then there are 2 moles of iron 3 oxide. Now, those coefficients are relative, meaning it's this number of moles in this equation. if I change the equation, are the moles going to remain that number? No. As soon as you change the equation, the moles change. Those moles are for that equation. Everybody with me on that concept? Okay. So, if I want to write a mole ratio, it's just a fraction. So, pick something in the equation you like. Xavier, give me one of those elements or compounds. Pick one of those elements or compounds out of the equation. Iron, oxygen. Oh, I just didn't hear you. Okay, so how many moles of iron are there?
4.
Okay, so we write 4 moles of iron. Sorry, I just didn't hear you. Over, Abraham, give me something you like that's not iron out of the equation. Okay, over 3 moles of oxygen. That's the mole ratio. Okay, that's it.
That's
Wait, got a question.
Yes.
So what if we use the compound instead of the word?
Okay, so give me the compound. How many moles are there? So 2 moles of Fe2O3 over, let's put it over something else. Give me something you want to put on the bottom.
Does it have to be out that equation?
Yes. Okay, so how many moles of oxygen?
3.
Moles of O2. All right, we can write a different one. Give me something to put on top.
Iron.
Hold on, let me answer Tiffany's question. Yeah,
So you put the number on the bottom behind it always, right? You don't leave it out.
I'm not sure I understand what you mean.
Oxygen 2, you put the 2 with it.
Yes, we're just writing the formula of the compound. So given that oxygen has a subscript on it, we always write the 2 on the formula, just like we wouldn't leave the subscripts off Fe2O3, just write FeO. We just always write their subscripts. So what now?
Can you make a compound?
Sure. So we can put 2 moles of Fe2O3 on the bottom. So give me something to put on top.
4 moles.
Iron.
Sure. So 4 moles of iron on the top. That's the mole ratio. Okay. That's the mole ratio. Can we switch equations just so we have some more variety in how we can write them?
So it doesn't matter how we write.
Nope, not as long as you don't have a word problem to work with. We're going to do it where we have a word problem in a little bit, but as long as I'm just saying write mole ratios, no, it doesn't matter what you write. Okay? So if we have this, for example, we have some 4 compounds and elements to work with. If I say write 3 mole ratios, can you write me some mole ratios?
Yes.
What's the first thing you should do?
Balance.
Okay, just making sure. Okay, so write me a mole ratio, 3 of them. And I'm going to call on somebody to come write them on the board.
I want to do a video. Me too.
I'll make it sound like I have 1 million followers and people are actually watching these things.
So,
You're famous.
right.
You're
You can be
famous
famous to
chemistry
other people.
teacher.
Nice to be noticed. That don't know chemistry. And want to learn.
Well,
Mm.
you would consider us friends, right?
Yeah.
In the loosest possible terms. Why?
Just making sure.
Okay. Did your coach let you know some of your athletic events have been rescheduled?
I figured they would have.
Okay.
Y'all had a game today.
JV and varsity baseball versus Oak Grove will be played
Saturday.
tomorrow.
You better not move.
You was gonna be mad.
Okay, those will be played tomorrow, and varsity baseball versus Atkins will be played at a later date. And softball versus Salisbury will be played on Thursday.
I thought we were doing better this semester.
Was.
Was. Isn't it the other song? What song was it?
I can't remember.
I'm going outside today. He started singing it, and I was like,
How many mole ratios do you want us to? I said probably 3. Just so when I call you, if I happen to pick you, that you have, something to pick from.
Get 2.
Awesome. What is the mole ratio even mean? We're going to use it to change compounds in just a minute. I'm going to explain shortly what it's used for. All right, so we had time to write a couple so that you can put them on the board?
Yes.
All right, go put one on the board for me, Tiffany. We're going to call on people who don't usually participate in regularly for me.
Oh,
I don't
Justice.
think you're gonna do
Call
it.
Justice.
No, Jamie does.
I know I ain't gonna do it. I'm not doing
You're right, Samaria. You I can count on to participate with me. If you weren't here, I'd probably be talking to myself.
Because Samaria catches on with it.
That's true.
I'll take Samaria place when she's not here.
I just like that.
Well, then next, about Wednesday, when things change up,
We'll see if you.
then we're gonna need somebody to take Samaria's place because we're leaving the math.
Hold up, I said I can do it on Wednesday.
I'm just saying, if you like math, then this is their chance to shine then. All right, somebody give me another one. Let me have, Jade.
I just ain't going up there. I thought I wasn't even. You write me in.
Oh, I didn't even see it right there.
I know you saw her. She saw her just school when she got at school.
I wasn't even watching TV.
And you wasn't paying attention.
No, to be honest with you.
I'm not the big bad one. Come on.
What's wrong, baby? I don't know, something's in my eyes. It's like 7 o'clock this morning.
Right, I can see it from here.
All right, let me have, Karen.
You're gonna worry her to just say that.
Oh my God.
What's the
Were you on time today?
bro?
You on time first period?
Yeah. I'm
Good.
trying to flush it out.
No.
And I can't see anything, so I don't know what it is.
Miss Wall, you be trying to be funny too.
I'm just asking a
She
question.
like Jessica.
That's a C.
She like Jessica.
That's a C.
Okay. Okay. All right, let's have one more. Darlene, good
Really
morning.
that much trouble to just flip the pen around and erase the line.
It's not balancing. Why are you looking at me like that? You don't need to do like balance. This is not balancing.
It really is bothering me because I can feel it. I'm smart. Yeah, she said she wasn't a big bad one. She was like,
No, I said I wasn't. She wanted me to.
All right. Everybody doing mole ratios.
Yeah.
All right. Let's see if we can
Let me
do something with them. All right. Now, for those of you who like titles, we're going to learn how to do 4 kinds of problems. Mole is the first kind of problem. So for those of you who like titles,
Yes.
all right, title is mole. All right. At this point, we have no new notes. Everything is just learning how to do a word problem. Now, this part that I'm putting in brackets, you do not have to write. Okay? You don't have to write the part in green. You need the balanced or the equation. No, it's not balanced. you need the equation and the part under the equation. That part you have to have. But the part about a spacecraft and carbon dioxide is just extra. You don't need that part unless you just want it. And I'll give you a minute to write, and then we'll talk about how it's different from your other problems. I'm not giving you very long.
So what do you want us to do? Just write down the problem right there?
Yep, just write the question, and then we're going to talk about it.
Tomas, you and Andy be dying over it every day.
It's funny. Chemistry's just fun. I wouldn't say all of that.
All right, we got it?
Jay writes slow.
Y'all write that part about the
She was
astronaut.
talking to be like, ooh, that's pretty.
No shit. She wrote the equation and she's writing the question.
Okay. All right, so as people are catching up, is the equation balanced?
No.
Okay, so let's look at the equation as people are catching up. See if you can balance it. See if you can balance the equation while people are catching up.
Jay, what's in a cup?
All right, what'd you come up with?
Yo, we ain't balanced this game.
Oh.
He got mad.
This was kind of hard.
All right.
It ain't even hard.
I was fast.
You ugly. 2422.
2422.
Yeah.
All right, let me write that down.
Okay, I had some.
2, 4, 2, 2. Now, if this was the test yesterday, would I have been okay with that?
No.
Why would I have not been okay with that? It can reduce. Okay, now let me tell you this. In this unit, will I take off for it?
No.
Yes, because you took out the mine.
I won't take off for it in this unit. Okay? If you don't reduce in this unit, it will work itself out and it will be okay. Okay? Because it will reduce itself and cancel in the calculation. So I won't take off for it in this unit. Okay? It'll fix itself when we calculate. Okay? However, it doesn't need to be that big. How many LIs do you have here? So you put a 2 there. How many C's? How many C's? Good. How many O's are here?
4. 2.
How many O's are here?
2. And then you added 2.
Quattro.
Guys,
Quattro.
for those people who are struggling to balance, y'all quit yelling 4 over there. I said, how many are here?
2.
And then how many are here? That's how those people got 4 that they're yelling out. So how many are here? Plus, how many are here?
1.
That's how there's 4 here and 4 here. Now, there's how many H's right here? Plus, how many are right here? 2. So it's balanced with just having that 2 there. But if you had 2, 4, 2, 2, it's fine. There's nothing wrong with it. And I'm not going to take off if you didn't reduce in this section because mathematically it's going to fix itself. Now, how is this question different from anything we've worked prior? First of all, it has a balanced equation. But if I flip ahead one question, does this one have a balanced equation written for you? No. So all of them are not going to have a balanced equation written for you. Okay? So when you read the question, how is it going to look different? How many moles of lithium hydroxide are required to react with 20 moles of carbon dioxide? How many compounds are there in the question? There are 2. Okay? There are 2 different compounds in the question. That's what tells you that this is different. They're giving you one compound and they're asking you to find the moles of a different compound. If we pulled the opening back up, it would say, how many formula units of sodium dichromate? Did I say any other compound in that question? No, it was only sodium dichromate. This question says carbon dioxide, and I want to know lithium hydroxide. That's 2 different compounds, okay? That's going to require you to have a balanced equation. Now, every time we solve and we have moles, what have we always used? What have we always drawn or used when we have a mole and we need to change? A T-chart. We're still using a T-chart, okay? So what is my given data? We're still putting it on the top line. Nothing has changed there. Now, if we want it to go away, where do we still put it? We still do. Nothing's changed. Now, this is the only thing that has changed. You ask yourself, are we changing compounds? If the answer is yes, you put moles on top. And you change the compound. So, are we changing compounds? Well, what did the question ask you for? It asked you for what? Lithium hydroxide. Is that asking you to change the compound? Yes, it wants something different. It gave you carbon dioxide and it wants lithium hydroxide. You are being asked to change the compound. So the answer is yes. So what must we put on the top line? We have to put moles on the top line. Okay? Now, this has a name. What is it called that we just learned to do if moles is on the bottom and moles is on the top? This is called a mole ratio. Okay? So, if we put moles on the top and moles is on the bottom, what did we just write down that the purpose of this thing was? To change a compound. So that's why when we do this, we're going to do what? Change the compound. So what compound am I putting right here? Well, what did it ask me to go to in the question? So I'm putting lithium hydroxide on the top. Now, in my chart, I will only have 2 compounds. The one they gave me and the one they asked me for. They gave me CO2. They asked me for lithium hydroxide. I don't need anything about those 2. Okay? I don't care about those 2. I only want to know about the one they gave me and the one they asked me about. Now, if this is a mole ratio, where did we get all the numbers that we just practiced? Right here. Where'd all those numbers come from? Where do you suppose these numbers are coming from? That's right. So, what number is in front of CO2? What number is in front of lithium hydroxide? That's where they come from. Okay? Now, all we have left to do is what? 20 times 2 divided by 1 is 40 moles of lithium hydroxide. Questions? Yes or no? Fabulous. All right. Can I turn the page?
Let's not do this.
Yes. Now, some equations have them written. Some don't. What if you have this one? Now, not all questions are going to be written for you. Write this down. Now, you see how I said ammonia up there is NH3? You need to memorize ammonia is NH3. You're going to see it again. You're going to need to know it's NH3. No one's getting out of a chemistry class without knowing ammonia is NH3. It's not on your reference table either. It's a base. It's in Windex. It's used in cleaners.
Wait, this lot, I need soap, but
Okay.
One. Green powder, yeah.
Huh?
I missed your class.
I missed the free food.
She mine.
Yeah.
I did that to somebody yesterday, by the way.
Oh, really?
They weren't impressed either. I told them to bring chicken nuggets. Hamburgers didn't work out too well.
You have a chair.
She just lying. You gonna let her get away with it?
Question
She
mark
said
on there.
30 seconds.
It's like this.
H2.
All right, we got it written?
Negative. It's not imaging. I mean, it's not imaging. You said you might teach next year. Yeah, I was in class the other day. It was talking about it.
All right, how about now? All right, so you've got to write the equation, right? So when you look at this, I color-coded things to make it a little easier because typically I've written, the pluses and the arrows, and this time it's in a word problem. Okay? So find the keywords like reacts, produced. All right? So when you have an arrow, a yield sign, right? This means produced. So what in this equation tells you something is on this side versus something is on this side? Ammonia is on the what? What's this side mean? The what? The right side, the product side. All right, so what's the formula for ammonia? Okay, so ammonia is NH3. And see how it says ammonia is produced. That's how Jaden came up with that. So NH3 has to be over here. Now, that means the other stuff has to be a reactant. So what reacts to make that? Hydrogen reacts with nitrogen. How do I write reacts with? Plus nitrogen. Now, these are elements, right? What do we know about them? So I put 2's on. All right. Is it balanced? No. So what do I need to do to balance it?
You're going to put a 2 on the product side.
Put a 2 on the product side.
And then you're going to put a 3 under the H and nothing in front.
Okay. Some of you had a tendency to do that on the test, which is fine. Most of you left it off, which is fine too. Makes no difference to me which way you do it. All right. So now that we have the equation written, all right, what did they give us in the question? 6.0 moles of hydrogen. Okay, so what goes on the bottom? of, because that's on the top. Is everybody good with us on that part? Okay? Whatever's on top has to go where? On the bottom, so it will do what? Cancel. Is everybody good so far? Okay, so you're asking yourself, what at this point? Are you changing compounds? All right, so find the question word in the question. What's it asking for? The who, what, where, when. How many moles of what? Ammonia. So what's ammonia? Okay, so it's asking me to find this, right? So if it's asking me to find this, and I have this, am I changing compounds? As long as y'all just answered yes, what has to go on the top? You have to put moles on top. You don't even have to answer the compound yet. But as long as y'all answered yes, the unit that goes on top has to be moles. Now, when you look at this, and the reason I say don't put NH3 up there yet, is you have to decide, is that a mole-mole ratio? Because sometimes these are going to be a mole and a gram. And that won't be a mole ratio, but that's a mole ratio, right? So this is where you go ahead and change it, and then we can put our NH3 up there. Now, since this is a mole ratio, where do the numbers come from? The balanced equation. So what goes beside NH3? And what goes beside H2? The 2 times 6 is? Divided by 3 is? Now, we know it's a 4. How many significant digits are here? So how am I going to make 4 2 significant digits? 4.0. Everybody good with that? All right. Let's see if we can do some of these. Now, these worksheets are divided up based on what I'm doing today. You need to be on the side that says mole, mold. We have not learned how to do grams yet. That's next. 6 times 2 is 12. Divided by 3. So what?
Like
Yes.
that. I know. I made an appointment with Miss Floyd to go.
All right, on the front side, all of the equations are written. All right, you're balancing and then writing the charts. What are the odds I'll pick up the exact right number? All right, you're balancing and drawing as many charts as you can before I stop.
Why?
Yep. Okay, so how many hens are here? There's only one. There's how many there? I'm gonna put a 2 there. So 2 times 1 makes 2. You made how many H's? But you had 2 there, so 2 times 3 made how many? So we had to put a 3 there, because 3 times 2 made 6. Okay, that's all we did. Yes, yes, yes. All right, all these equations are written. So you don't have to write any. All you have to do is balance and draw your charts. Okay, so balance and draw some charts for me. I'll give you a minute to get started, then I'm going to poke around it. Be a pain looking over your shoulders.
I need to help.
What do you need help with?
Everything.
Try balancing the equation, draw charts. I can't help with anything until you've done something. There was an English teacher here once upon a time that said you got to put something on a piece of paper before I can help you. So try that. I got to have something to look at. Okay, so draw your chart. Put what you can in the chart. Let me see what you got. Question.
Actually, yes, I do. But it's not like very important. Okay, so what if, are we gonna get to know if like we're not changing the compound?
What we did before,
Oh.
was, when you come out, like in these charts, yes, in a few minutes. We'll have a section where we do change the compounds, and then we'll have a section where we don't change the compounds. In the section where we don't change it, we're gonna go brands. And we'll have a mold brand section. The mold section is where we'll have the mold ratio. Section where we don't will be mold grams. Question, Tomas? Yeah.
What if they're already balanced?
Then it's already balanced.
And then you just draw the chart.
Yep, and we'll have a 1-to-1 ratio. With that, asking for moles of iron hydroxide, and you've got moles of potassium hydroxide. Balance, chart, come on. Come on now. What's this? What is that compound? What's that? What's that? Oh,
I mean, it's,
so what's that?
that's what propane is.
Yes. To use the process of elimination.
Just extra.
Yeah.
Well, I was thinking about combustion. I'm like, that ain't some already on the fire.
You go good?
Yeah. All right, so what compound has to go on the bottom? Moles of this has to go on the bottom. Whatever's on top goes to the bottom. No, just the unit and the compound. So moles of KOH. Okay, now whatever they ask for goes on top. So they ask for how many moles of what? So moles of iron hydroxide goes on the top.
That's right.
Okay, and then the coefficients that go with that, does your mole ratio.
They could be both.
Yes. What's wrong over here? Why are you hollering it's probably wrong? It's balanced, right? This is KOH, right? So whatever's on top has to go where? So that should be KOH in the bottom. Just because it uses a compound name in the question doesn't mean it has to appear in the chart, okay? Could be just right for you. Moles of KOH on the bottom. What's it ask for on top? How many moles of iron 3 hydroxide? Moles of iron 3 hydroxide. Now that we've fixed your compounds, what coefficients from KOH? There's a 3 there. And that has a 1, so calculate. Okay.
I have a question.
What's the question?
Did I do this right?
I don't know.
I feel like it was too simple.
Common ratio, so yes, you did do it right.
What is propane?
Fabulous tip. All right. Tell me what this is. Water. What's that? What's that? What do you suppose that is? Turn y'all back here. Johnson, where's Ariel?
Oh, yeah.
How about over here?
I don't think they do that, so.
All right, right here.
I get that.
What is in front of KOH? What's supposed to be in front of KOH?
Is the back the same thing?
This is, no, that's the new part. We haven't done gravity yet. Moles of potassium hydroxide, right? Moles of potassium hydroxide. So supposed to potassium hydroxide. KOH. So you do your chart, what's going to the bottom? Okay. So, hold on, which numbers do you have? So, are we changing compounds? So that asks moles of what? So we need two moles here, our unit and compound goes to the bottom, we got to match. So are we gonna be changing compounds? Yes, because they want what? They want iron hydroxide, and we're not potassium hydroxide. Put mold on the top line, and we need to change compounds. Which compound we need to change to? See that reaction, iron, chloride, junk, we don't need that. We don't care who it reacts with. Find your question mark, how many moles of what? That's the important one. So that's one that needs to go on top of that moles. Okay? Now that we have our mole ratio, that gets filled in with what?
What is
Yes.
propane?
I think it's
For those of you who keep asking which one's propane, in that equation, tell me what H2O is.
water.
What's the O2?
C3.
Carbon dioxide. O2 is what? Oxygen, so the thing that's left over would be the what? Propane. If they gave you something like octane, which is C8H something, that would be the something else. Butane is C4H10, I think. So even though you won't know the names, okay, whatever's not those other three compounds you do know, that other compound is what it is. Okay, so what's going on the bottom line? Or they ask you to find. So that has to go where? Yeah. Now, what number are you putting beside moles of FeOH? Moles of FeOH, first of all, looks like that. Write it like that. And what coefficient goes in front of it? For one minute. And calculate. All right, who else has a question? Yes. No. Balance regular instructions, even there, on top line. On what? Which one of those is potassium hydroxide? Just potassium something. Yep. All right, and what do they ask us to go to? All right, your question, how many? Which one of those is iron 3 hydroxide? See, that says how many moles of iron 3 hydroxide? Which one of those is iron 3 hydroxide? Mm-hmm. 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 Yep. Exactly. There you go.
Which one?
I believe those are right. All right, let's talk about some answers. What you got? That's still right. I know the first two off the top of my head. I think I gotta get my other notebook. I do.
Are you volunteering for that Dr. Hollow thing?
For what?
The Dr. Hollow. Y'all name moving on Holly? No. If you would like to volunteer this Saturday with the Dr. Holly from 1 to 3, please stop by the PP office. The PD. I'm gonna go by there because last time I think I sent her back to her message that she put, okay, never mind. I'm like, My bad.
She be getting mad at people. I mean, that's okay. That's what it says.
All right, I'll go for 1, 2.
I get what I'm working.
Oh, where you working?
All right, let's see. I can find my sheet.
I don't like kids. Can't be no daycare. I can barely stand people in this high school.
You know what you
All right, number 1 should be 0.128 moles. Number 2, 0.3 or 3.8 moles. Number 3, 3.75 moles. Number 4, 2.25 moles. And the last one, 7.2 moles. Number 1 was 0.128.
What was number 3?
Number 3 was 3.75. 2.25. 2.25.
Okay.
Jay, did you have number 2?
Do you have coefficients of 1, 5, 3, and 4?
I didn't get one right. I thought I got
If you don't have coefficients of 1, 5, 3, and 4,
it.
do you have 2, 10, 6, and 8? Then you'll be fine. Bring me your chart.
Which one you find?
Can you do number 1 for all?
Bring it here.
For me?
Yeah, you. Because this says you have 0.750 moles of propane. So there should be C3H.
8.
Yes.
Okay.
So get rid of this and
Wrote
make
it
it.
backwards.
Yep.
Okay.
So that should be C3H8. And then flip
Then
these two.
put this- Okay.
You have, you punched it in wrong. That's this times 1 divided by 3. My guess is you hit multiply because your chart's right. Because your chart is correct. All right, anybody else have a question? All right. In that case, for those of you who want titles again, last title for the day. Mole, gram. Okay? Mole, gram. For those of you who like titles. Okay?
I mean, it's Tuesday.
Okay? Write it down. Mole, gram.
I'll probably end up doing it. That's okay. We got right now all that.
Yeah, because that whole tangled mess is writing the equation. You got to write the equation this time. It's not written for you. So that whole big description is how to write the equation. And
Hey.
All right, how about now? Am I giving you enough time?
Yes.
All right. Who said no?
Thomas.
All right, we got to be able to do this one so we can do our homework tonight.
Oh, no. Homework.
I need you to.
Don't whine. Y'all know you have homework. All right, so I don't care if you do it or not. Your grades are yours. Now, when you look at the question, you have to write the equation, right? So again, same process. What does it tell you is produced? What does it tell you reacts?
It produces glucose and oxygen.
I want you to do me a favor. The whole question, I want you to say nothing. Okay? Make them talk to you. All right? Because they're counting on you talking. So, what does it tell you is produced?
Glucose.
All right, glucose and oxygen. So, how do we write glucose? Because I gave you that formula. All right, and I just wrote oxygen because I'm assuming we all know it was diatomic, right? All right, from what?
Carbon dioxide and water.
So carbon dioxide is,
CO2,
and,
H2O.
all right, so we need to balance it, right? So when I look at this, we have how many C's? How many here? How many here? So I'm putting what here? Okay, how many H's? How many here? So I'm putting what here? 6 times 2 is 12. Now, the O's are what usually get people in this equation. So see if you can follow my logic and how I'm balancing this. Okay, I have how many O's here? I have how many O's here? I have how many O's here? So, if these balance these, what do I have here? I have 12 here, right? So, what can I put here to get the same number? Just put a 6 there, and then I'll have 12 there, and it'll balance, right? Okay. Let me get rid of those. All right, so this time, what was I given in the question? 3.00 moles of water. All right, so what goes on the bottom? All right, so you're asking yourself, are we changing compounds? Are we? What do they want? They want what of glucose? They want mass, right? Every time you read mass, what unit is mass? Grams, okay? So, we're changing compounds because we want what?
Glucose.
We want glucose, okay? So the answer is yes, we want glucose. So, we're putting moles on top, okay? Every time you answer yes, you have to put moles on top. So, if we want a different compound, we're putting moles on top. This is called a what? What do we call this thing? This is called a mole ratio. Okay? Anytime we have a mole ratio, what do we do with a mole ratio? What do we just practice?
Take the coefficient.
Check the coefficients and change the compound. So what compound am I sticking up there? C6, H12, O6, right? And what coefficient was beside glucose? And what's beside water? Okay, this is what we just practiced. Okay, it's all we did, right? Now, this is the new piece we're adding for the homework. I know, homework is a dirty word. You're adding a section.
So what moles C6 H12?
That's right. So the moles of C6, H12, O6 go on the bottom. Okay. Are we changing compounds? And the answer is no. Why is the answer no? We already did it, right? No. So we're putting grams on top. Okay, so we're putting grams up here. So if we put grams on top, are we going to change the compound? No. So C6H12O6 goes on top. Now, this is the old conversion we've been doing for weeks. Okay, weeks. What number always goes beside mole? 1, okay? This is your 1 mole equals gram we've been doing for weeks. So we get a 1 there. I don't care if it says 12 right here is a coefficient. It still gets a what? A 1. What goes there for mass? What do we always put beside a gram? Y'all are still staring at me. Molar mass. Very good, Tomas. Okay, so we need molar mass. How are we going to get molar mass?
Adding up all the elements.
Got to add up all the elements. How many C's are there? How many H's are there? How many O's are there? Carbon's mass is 12. Hydrogen's a 1. Oxygen is a 16. You get 72. You get 12. You get 96 for a grand total of 180. So I'm going to put 180 right there. Okay, so how do I punch that in my calculator? 3 times 180 divided by, you get 90. I need 3 significant digits, so I'm going to put 90.0 grams of C6H12O6. This wall's got mad calculator skills.
All the ones on bed. Or you messing up the sheet?
It's 11:35. I really wanted to do a second one. Can we do a second one but not write it down so we can just look at it?
No.
Y'all are going to be lost when you're on work tonight. And then come in and be like, I don't know what I was doing, Miss Wall.
So don't give it to you.
We're still doing it for homework. So stop packing up. We got 5 minutes.
But we're not writing it down.
Yes, we don't have to write it down. We can just watch. Yeah, you can just write glucose. All right. Yeah, but if y'all are packing up, you're not paying attention. You don't leave till 11:40. All right, so let's say that we have this one. Okay? So, is my equation balanced? No. All right. And yes, y'all are doing the back side of that sheet for homework. So we have a 2, and we have a 2, right? So what do I start with in my chart? 2.00 moles of what? Magnesium. All right, Samaria, you're barred from speaking. They're going to not listen. Now, y'all can wait to do that until it's time to go. Y'all can do it on the way out. Sit down. Everybody will be up not paying any attention. The bells aren't ringing, so sit still. Now, what goes on the bottom? Moles of what? Moles of Mg. Now, do we have to change compounds here? What they ask us for in the question? Abraham, you're studying your pencil. What they ask us for? Magnesium oxide. So if they're asking for magnesium oxide, are we changing our compound?
Yes.
So do we need moles or grams on the top line? Moles. So what goes beside the moles? MgO. That's the mole ratio. So where are the numbers going to come from tonight? The coefficients. So I'm going to get a 2 and a what? All right. If I wanted moles, I'd be done. But they asked for mass, right? So what goes on the bottom? Moles of MgO. And then, am I changing compounds? So I put what on top? Grams of MgO. Now, this gets a what? It gets a 1. Does it matter that there's a 2 right here? No. I only get to use those coefficients how many times? 1, and this is always 1 mole equals grams. That never has a coefficient. That's 24 plus 16, so 40.3. Questions about how we did that? Now, on the back side of that sheet, you got to draw charts. If I check homework tomorrow and all you have are numbers, you're not getting any credit. Any questions about that? All right, I have 11:38, which means we have 2 minutes. If you still have a calculator, put it in the tub.